Morning, everyone. I'm going to post the second part of the notes for Lesson 6 in Unit 8. Today we're talking about finding solutions to quadratic equations and factoring quadratic equations. Sorry, that was my computer going off there. So, as we move down into the notes, yesterday we kind of looked at where zeros fall on a graph and how to connect that idea with the idea of factoring trinomials and then solving for zeros. Today will be a little bit of the same, and if we go right down to the exercise number 2 at the bottom of the page, it says that we're going to use the zero product law, which the definition is right above it, and it states that if you have two or more quantities, or rather if two or more quantities have a product of 0, then at least one of them must be equal to 0. And you'll see that we're actually going to set both of them equal to 0 because we're solving for zeros. Now, looking at exercise 2, it says, or rather part A, it says that we want to set the two binomials x plus 7 and x minus 2 equals to 0. I'd like to almost go back a step, and I'd like to figure out what's the actual function that we use to actually factor out two binomials. So we're looking for a trinomial in this case. Now, if we do our FOIL, if we multiply these two binomials together, we multiply the first term, we multiply the outside terms, we multiply the inside terms, and the last terms. That's where I get the acronym FOIL. We can actually find out what the original trinomial was. So, doing some quick math, x times x is x squared, x times negative 2 is negative 2x, and 7 times x is 7x. You put them together, 7x minus 2x is 5x, and then 7 times negative 2 is negative 14. So there is our original trinomial, and it was able to be broken down into these two binomials, x plus 7 and x minus 2. Now I know that this function, x squared plus 5x minus 14, is a quadratic. It is a parabola that opens upward. It will have a minimum, and it will have two roots, or two zeros, or two solutions. I'm going to show you what the solutions are right now. The next step would be to solve for x. We'll set both of these binomials equal to 0, and then just solve it like a regular old equation. So I'm left with x is equal to negative 7. There's one of my zeros. And x is equal to 2. There's another 0. Now, what can I do with them? Well, first I'll highlight them. And let's just be clear that a 0 is the same thing as a solution, which is the same thing as a root. All three of these names mean the same thing. Now, let's take this information and transfer it to our graph. So I said it's an upward facing parabola that crosses the x-axis at 2 points, because we have two zeros or two solutions, one of them at negative 7 and one of them at 2. I know that the minimum falls somewhere in between based on the symmetry of a parabola, and it should look a little something like that. Now, if you wanted to verify, you could graph your function on a calculator, and you'd get a parabola that looks identical to the one that I just drew. On your table of values, you'd have these 2 points, negative 7, 0, and 2, 0. And you'd have a minimum located somewhere in quadrant 3. All right. Now, let's look at a more complicated example 2x minus 1 and 3x plus 4 as our binomials. And again, let's look back and try to find our trinomial. So I'll do FOIL. I'll multiply the first terms, the outer terms, the inner terms, and the last terms. 2 times 3 is 6. X times x is x squared. 2x times 4 is 8x. Negative 1 times 3x is negative 3x. 8x minus 3x is 5x. Negative 1 times 4 is negative 4. So there's my original function. Now, I want to find my zeros. I'll set both binomial factors of the original trinomial equal to 0, and then I'll solve. And again, we are looking for our roots, our zeros, our solutions, where it crosses the x-axis so that we can graph it. Now, I'll add 1 to both sides, and I have 2x is equal to 1, divide by 2, and x looks like it's equal to 1/2. I'll solve my second binomial, subtract 4 on both sides. 3x is equal to negative 4, divide by 3, and I have x is equal to negative 4/3. Now, both of these roots, or zeros, look to be fractions. They're rational numbers. Now, if I was to graph them on the coordinate plane, negative 4/3 is a little bit to the left of negative 1. It's just greater than negative 1. It's actually negative 1.333 repeating. And 1/2 is half of 1 on the positive x-axis. And I see that my parabola looks to be very skinny and narrow. The distance between my roots is small. But notice, all we're doing here is identifying our roots based on the binomial factors of the trinomial quadratic. And that's it. Now, I'd like to go to the next page, and I'll do 2 examples on the next page out of the 4, and we'll see if you guys can follow along with me. So exercise 3 says find the roots or solutions, same thing, to each of the following equations by using the zero product rule. So I guess we can just say it's really solve by factoring. So the steps, if you will be to factor the quadratic and then to solve for x. Now, this goes back to our polynomial unit where we have to factor trinomials into 2 binomials. And mostly all of these are of the same format. If we're looking at letter D, I'm going to exclude that one actually because the coefficient of the x squared term is not 1. But looking at letter A, we'll start with our 2x's. And again, you're looking for a number that multiplies to negative 12 and adds to positive 4. Well, immediately 6 and 2 stand out in my head. And if I multiply a positive 6 by a negative 2, I get negative 12. And 6 plus negative 2 is positive 4. My factors look to be positive 6, negative 2. Now again, we're looking for 0, so once we factor our quadratic, we solve for x. We set both of these binomials equal to 0 and solve. Our 2 zeros in this case are x equals negative 6 and x equals 2. And that's where our graph would cross the x-axis. And it would look something like that. Okay. I'm going to pause there for today. If you want, you can attempt letter B and letter C. Letter B has actually a common factor of the 2 terms. And I'll give you a hint. If you pull out a 2, you can multiply the first term by x squared and the second term by negative 7x. And from there, you can actually pull out an x, and you're left with 2x and x minus 7 as your terms. Set them equal to 0 and solve for x. And for letter C, it's an example of a perfect square. Now, I know we've done questions like this in the past. You should be able to come up with the factors for this quadratic. Hope you guys have a great day. Talk to you soon.